Okay, so now let's look at these applications. Tires have tread on them to channel away the water and improve grip on both wet and dry surfaces. The height of the treads on a tire is referred to as tread thickness. The table shows the tread thickness of a particular set of truck tires based on the number of miles on those tires. So when they say based on the number of miles on the tires, we know that the miles in thousands is going to be our input, and our tread thickness in millimeters will be our output. As you might expect, this table shows that the more miles you put on a set of tires, the less tread there is left on those tires. That's why tires don't last forever. Do you think it's reasonable to predict that the relationship between tread thickness and miles driven is linear? Why or why not? Well, to be honest, I would like to see more than 2 points to make that assumption. I mean, between any 2 points, there's one line, right? So I'm not really sure this is a great question in this particular unit. So it says, let's continue on the assumption that tread thickness and miles driven are linearly related. Okay. Find the rate, that means they would like the slope, at which the thickness is changing compared to thousands of miles driven by comparing change in thickness to the number of miles driven in thousands. Okay, so they would like the slope, which is y2 minus y1 over x2 minus x1. So let's let this be x1, y1. Let's let this be x2, y2. All right, so 4.8 minus 7.2 divided by 35 minus 15. Okay, so that's going to give us a negative 2.4 in the numerator and a 20 in the denominator, which will give us a negative 0.12 millimeters per 1,000 miles. I needed one more M there for my millimeters. Okay, so yeah, that is our slope of the line, isn't it? And then number 3 says, why is it smart to write miles in thousands rather than the actual number of miles? Well, if we went with just miles, the slope would be a really small number, which would be harder to make sense of and a little bit harder to work with. Really no need in writing that down. That's more of an opinion question. And then number 4 says, use either one of the ordered pairs in the table. Let's use this one to write the point-slope form of the equation that describes the relationship. So remember, the point-slope form of a line is y minus y sub 1 equals the slope times x minus x sub 1. So we have y minus 7.2 is equal to a negative 0.12 or negative 12 hundredths times x minus 15. And that's really all they wanted there. Now, if you use the other point, you could have had y minus 4 and 8 tenths equals negative 12 hundredths times x minus 35. Okay, either one would have been fine.